tracing this curve, which is actually a parabola curve. So here, we're still in a two-dimensional world where the circles are growing and the lines are moving. All of a sudden, the camera has moved and we're revealing that there's a 3D perspective of the same thing. In the 3D world, time is now just another dimension going down through the screen. Time is basically this dimension going down through the center of the cone, or what was originally like into the screen. For example, so as the lines are moving left to right, they're actually also moving down, and they're intersecting the circles, and the circles growing at a constant rate through time is the same as a cone in this 3D picture here. So what does it mean to say that concentric circles in the 2D world meeting with lines is forming a parabola? What that means in the 3D picture is that if you slice a cone at the right angle, then you'll get a parabola. So parabola is a sort of special conic section, that's what they call it. This one is titled A Method to Draw Infinitely Many Touching Circles. Catch you down, what's happening here? Well, actually it's drawing out a circle. What I want to do is get a nice pattern with lots and lots of circles inside this original circle here. So if I was to draw, instead of drawing a straight line, I'm going to draw a circle. I'm going to start drawing circles in this grid here and see what happens to the point down here. So the first circle we're going to draw here. And you can see that it has corresponded to a circle down here. And it's touching the big circle because this one is touching as well, right? Now let's draw another circle. Drawing another circle at this point. Now this one is touching the original big circle, which is this line, and this one here. So this new circle is touching, as you can see, these two. Yeah. So it's kind of obvious how to draw two circles that touch a line up in this world. Less obvious is the exact sort of radius that you need to just fit snugly like that in that world. So you just continue to keep drawing circles up this world up here. And now we're getting smaller circles because they're more distant. We have the establishing shot of what's happening. We draw the straight line which corresponds to the circle, and then we just start drawing the circles above the line. Goes crazy drawing all these circles, and zooming into the picture below we get this intricate pattern of infinitely many circles underneath. What this really is a geometrical construction called circle inversion. Amazing. You'll never be able to look at circles the same way. The way that this would be normally presented, I think, is that you start with a circle. Let's simplify and say that the radius is 1. I'm wondering, where does this point get mapped to? So this point will get mapped to somewhere along the line that connects the center of the circle to that point. Imagine that this distance is r. It will get mapped to the point inside the circle that's at distance 1 over r. And so, there's a special point here. Here r equals 1 over r because the radius is 1. Anywhere inside here will get mapped, way out here. Here gets mapped like here, and so on. And this has this property that if I draw a circle in that picture, then it turns into a circle outside. And also if you have a straight line like we had here, then this can be thought of as a circle with an infinite radius. So it would correspond to a circle down here that goes through the center of that circle. The center of the circle gets mapped out to infinity. I like it because what I've done is I've thought of a geometrical reason for how we could keep this constraint of mapping from r to 1 over r, and that is in this picture, if this is r, if the long side of the rectangle is r, then this has to be 1 over r, and that's just because we're saying that the area has to equal 1 at all So it's kind of like a sneaky way to say, to get all the nice properties of circle inversion. And you know, one nice thing you can do with circle inversion is create these pretty pictures of infinitely many circles touching each other. It really is a trick. I didn't really do all the maths to figure out, you know, what radius and where the centers of all these complicated circles should be. I just did this much more easy grid structure on top.
This episode was supported by KiwiCo, providers of these great subscription crates, an amazing hands-on way to get excited about science, technology, engineering, the arts and mathematics.